I think science is observation, it's coming to conclusions, hypotheses.
There's more than one type of science. Life science is with life, living things. Regular science has magnets, electronics.
It's about exploring your surroundings and seeing what conclusions you can come up with and using that to further ideas and observations.
Science is a matter of, well, it's life. There's life science, there's earth science, there's lab science. There's different kinds of science, and we use them for everyday things. Science is fun for me. I enjoy science.
STEM stands for Science, Technology, Engineering, and Mathematics. And in our camps, we seek to integrate all four of those components into a cohesive message where the kids experience those four things as one particular thematic unit.
Science, technology is a big pop word now. We are a culture that loves science and technology, science fiction. The best shows on TV are science-based, and so for most people, technology and science are synonymous. And when we turn them into a STEM camp, science is really thinking about why. It's asking a question and finding an answer, and how things work in a physical sense. We essentially take this science and technology and make it hands-on for kids. We bring it down to a level that they can understand it, whether they're 7 or 17. We bring it down to the level or up to a level. We get rid of the Greek and Latin words that seem to turn medicine and science and technology into a foreign language, and we put it into the kid language. And all of a sudden the kids look around and say, I'm familiar with this. And they're familiar with what we're doing, and familiarity is comfort, and it's no longer a scary thing.
Does have building instructions. So in our camps, NXS camps, which stands for Innovative Experiences in Science, we utilize a number of materials and websites from NASA and Jet Propulsion Laboratories that helps our students, our campers, exceed in understanding the materials and really helps in the critical understanding of some of the concepts we present. You see, with the materials, which some people would call toys, we allow them to play and experience some of the science and engineering that goes into it. And then the websites help provide information that allows them to synthesize what they've been working on.
I think there is a perception that STEM is scary, that's a little bit misguided. I think that a lot of people don't realize that we use STEM kind of in our everyday lives without really realizing it. A lot of the thinking and methods behind STEM are used subconsciously on a day-to-day basis to help us get through lives.
STEM sounds like it is a part of a plant, but it really is an acronym for Science, Technology, Engineering, and Mathematics. A plant stem keeps the plant upright and growing. Technology keeps us on track with life and its problems. Plant stems transport supplies to parts of the plant that need help. Engineering is needed to solve problems worldwide, just like a stem. Plant stems need to know what they're supporting and try not to overdo or underdo it. Mathematics are needed to know what is possible and what is not possible.
technology is making the best of your surroundings and using them for innovations. I mean, when you think about cavemen and you think about how they made fire, that was a technological innovation. And if you compare that to nowadays cell phones, I mean, the fire to them was a cell phone to us. And it's just making the best of what you use around you and using it for different things and using it to better your surroundings.
Mathematics is nature. There's mathematics in everything. Mathematics is not just numbers, addition and subtraction. There is a pattern in every tree, snowflake, pineapple, sunflower. The Fibonacci sequence can be found in pretty much anything. So mathematics is everything. So.
Well, I do think science is fun because you can do all these experiments and you can mess with it and twist it and do anything with it. And a lot of things here, science is all around us and you just have to find it.
I like science because I've always dreamed of being a scientist. So I could so I could do different things every day. I could build and then I could take apart and then rebuild, and then take it apart and rebuild.
We've taken evidence-based research and included that into our camps so that we can look at raising young folks, our campers, to think scientifically, to think not necessarily in the box, but out of the box. And by using the research that's been provided by a number of organizations like the National Science Foundation and NASA and S.T.E.M, we've really been able to push that idea through imagination on the box of their thinking and really have them exposed to new ways of thinking. And I think that's an exciting way that we can look at raising a generation that may be the future engineers and scientists here in America. Our campers make better connections when we match science and engineering, because if you think of it, science can be somewhat as the thinking component, the actual how-to. But engineering is what makes it work, the actual struggling with the concept and trying until you come up with a problem that can be solved. And through that trial and error, I think they understand the principles that are behind the science through practicing the engineering.
Again, it's you find something they want to do and you put an educational spin on it. So, maybe skip counting teaches counting. You can do hopscotch and use the numbers and get that to turn into multiplication problems that they have to solve. And so it's just different ways of taking what people consider normal everyday activities and looking at it from a slightly different perspective and making a point to it.
There's a number of tools that we can use to make math more exciting for kids, and often we try and sneak it in. We sneak it in with robotics, we sneak it in with using the microscope. And you kind of go, well, isn't that just science? Well, there's a lot of math that goes into making those things understandable. The more they do, the more they experience, the more math they use, everyday math, that gets them thinking about math around them. And I think that's an exciting component of using experiential science and learning. Imagination and research are important components of our science program in that we look to take the imagination of the kids, expose them to great models that have happened through science and engineering, and then have those kids experience their own imagination in creating things in our camps. In the background, we're looking at the research that goes into mind development, and recall, and memory, and looking for ways, maybe even new ways, to develop learning with kids and bringing in the motivation and excitement that comes through them being involved in the creative process.
Imagination and research are important in science. They're embedded in science. Plato and Aristotle had a big argument a long time ago, and Plato said, you can just know things, personal revelation, or God will tell you things, divine revelation. And Aristotle says, I don't believe it. And he says, we need to be able to prove and see physically. And so we have research-based Aristotle. We're going to go out and physically prove this again and again. It needs to be repeatable. And in a way, both of them, Aristotle's still talking about imagination, but it needs to be measurable in his mind. And Plato's all about imagination. He's all about allowing that thing that we really can't explain exactly to come out. So imagination is in both. It is science. Without it, we don't make discoveries. And research is science because we need to be able to prove it again. Somebody else needs to prove it again, show it again.
Imagination leads to research. You imagine what you want to find out. You imagine how you're going to find that out, and then you start building experiments and hypotheses around what you've imagined, and that turns into science, and you start finding out whether your imagination holds up or not under reality. Once you've found that out, you can adjust your imagination to better reflect reality and really start it over again. You imagine it again, research it again, and that's science.
Technology is actually all around us. Technology is nature. Technology is life, if you think about it. So that's how we incorporated into it, and the kids did really well with that, and they picked up on all of it, and I was so proud of them. Well, honestly, I think Iron Man, to me, would be the most technologically advanced because he was a scientist. And he was also a radioactive scientist. He did a lot of different kinds of things. And I think he would be the most out of all of them because he was sort of not only just scientist, but his father was one. His father made stuff in World War II, like they showed that in Captain America. They showed that he had built the ships, that he had built the bombs, everything. So he sort of inherited that, and he created weapons, and he decided to change it after witnessing that his weapons were being used against his own country. He started to look into clean energy. In the modern day that they showed during his timeline, he had made a lot of different changes to the technology, like the different phones, and they have the computer that comes up, and it's got all the touch sense and sort of three-dimensional holograms and stuff. So I think to me, he'd be the most technologically advanced one.
Captain America, because he was just a skinny little guy, and then he got some special super juice injected into him, and he got larger and stronger, so that would be a scientific superhero because he was made with science. I think Marie Curie would be a real-life superhero, real-life scientific superhero because she gave her life to science. She discovered lots of elements that nobody had ever thought of before. She tested them. She discovered how radioactive they were.
One of the ways we make a story out of science is we choose a theme. Many of our themes this particular camp were really great, like we chose superhuman powers, incredible universe, invisible universe, a number of those. And with that theme and kind of capturing some of the blockbuster movies that have been out this summer, specifically with superhuman and superpowers, we're able to look, I think, with kids' already motivated interest and take a deeper look into the biology, into the physics, physiology of what goes into superpowers. When you capture that, those kinds of themes, kids are already interested and you've got them for the whole week. The value of making story a part of learning in our camps is that you have a continuity to the message that's being told. So we make a thread that draws the story all the way through the camp and allows the kids to recall better the science that they're learning. So if you had a character and you develop that character, and you might have a villain, well, in our superhero camp, they learn the science behind those characters in the villain and the good guy, and then also what makes it possible for them to be superhuman.
It's you who's be thinking about your story. If you were going to be a superhero, what are you going to do with your life that makes you a superhero? Heroes are agents of change. They change the world. They change the community around them.
I believe that storytellers are our oldest teachers. In order for us to be good teachers, we have to have a way to capture attention, to include the audience. These are all factors in storytelling. And I believe the value of storytelling in science and in teaching, it is probably the most important value. If I was to take a room of people, the real leaders and teachers in there, capture people's attention in the things that they say, there's something about them that captures that attention, and then they are able to relate to others by the storytelling. They come down to where those folks are at, they can identify where that person is coming from, they tell the story in a way that's meaningful to the people. So I think it's possibly the greatest value.
Of what we saw on the video, and also because a lot of rides use magnetics, because on a roller coaster, if you're going a steep hill, the roller coaster.
I think that science is not just standalone. I think it's, again, part of everybody's life. And so when you write a story, you almost have to include science because it's affected that life, and you can't leave out the effects of science on that life without ruining your story. I mean, you start to feel like pieces are missing, that something isn't there, something was left out. And so when you write a story, you almost have to include science because it's a part of everyday life.
Storytelling can bring science to life. Often we think of science in a vacuum, and you learn by the textbook and you regurgitate that on a test. Well, in this kind of situation, storytelling means you include other people in the story that you tell. And it brings a sense of community and understanding and excitement as the story of science unfolds.
And as it moved downhill, a couple things started happening. The surface of the flow started cooling and becoming solid rock. The bottom of the flow, in contact with the soil and the plants, also began cooling, became solid rock. And it turns out rock's an amazing insulator. So the interior of the flow stayed hot and kept moving. Once that eruption stops up there, that lava is going to keep flowing downhill. And it'll go farther and farther and farther, while everything behind it is potentially drained out of that solid brine. So that is a little bit of the story of where you're headed. Now, once we're in the cave, it's going to get kind of dark, but you're going to see this tunnel-like structure. The floor of the cave is absolutely lava, and that's the last bits of the lava draining out. But all around it is also lava as well, and that lava was solidifying, kind of making the walls of this tube. Around the edge of this lava wall, you can see the very different texture. That's
that one's not going, it's dead. Thought it wasn't moving. This one moves perfect.
When we went up to Bernie Falls, we sort of incorporated the whole science sort of theme into the waterfalls, which was a little hard to do at first, but when you get there, the kids start taking a look at sort of, I guess you could say, nature's technology, about how certain things in the environment will affect the living beings there.
Well, the trip has gone really long. This is one of my favorite things about it. We're right here where the bottom of a lava flow was coursing over an ancient landscape.
Oh, wow.
Kind of see how bubbly it looks under here. This would have cruised across a soil horizon. And when you kind of look up, you start to begin to see, especially straight above us, the cooling features of this lava flow, which is pretty thick. It's about 40 feet thick. But these great pentagonal and hexagonal shapes here are markers of the cooling of this fairly thick lava flow. This lava flow came from Everett Hill, which is the ski park.
This came from where we were just at?
Just at.
Wow.
And right now we're about 10 miles away, but the rest of this lava flow goes about 30 miles down canyon.
Wow.
Scientific achievement is related to the achievement of humanity. Humanity coming from a status where it's a part of the environment, and now humans have risen to a point where we are above the environment to some degree, starting to exist outside of the environment, and all of the changes in technology that made that possible. That is the story of science and technology. So from a historical perspective, I believe that what we're seeing is science is telling the story of humanity and our struggle to overcome, to survive, to survive as a species. And so I think that that's the relationship between history and science.